All right, so we are going to be looking at using the formulas for chain rule to do chain rule instead of doing either the inside-outside rule or explicit chain rule. Okay, so what I mean is, like here we have a product rule, but then we have this chain rule. And the chain rule variant for the exponential is the derivative of e to the u is e to the u times du. So these formulas, if we have them memorized outright, we can actually use them to our advantage when we're doing other derivatives. And it keeps us from us having to actually stop and do an entirely different rule. Okay? So if I'm taking the derivative, I'm going to have to use product rule because I have x squared, the quadratic, times the exponential. So the derivative of the first, 2x, times the second, e to the 2x, plus the first times the derivative of the second. And when I go to take the derivative of the exponential, I have to do chain rule using this rule right here. I get e to the u times the derivative of u, which is 2. And that is my derivative. So you can see very quickly, having these rules memorized outright keeps us from having to stop and doing another rule in the middle of it. Now, inside-outside rule works very similar, but you're doing a process inside of another process, which often sometimes confuses us. This is like as if you were doing multiplication that you've had memorized in the middle of an algebra 2 problem. Okay? So same thing here. We have this function, we have product rule going on, but then we have this derivative of sine doing chain rule. And again, I'm going to write it out. So if I'm taking the derivative of sine u, that is going to be cosine u times du. That is the chain rule variant for sine. So when we go to find y prime, take the derivative of the first. Derivative of cosine is negative sine x times sine 2x plus cosine x times the derivative now of this using my chain rule. It is going to be cosine 2x times 2. And again, just using this formula to help us out in the middle of it. Okay. Here we have quotient rule, or if you want to, some people prefer to do it product rule by changing this to natural log of x squared times dividing by secant, the same thing as multiplying by its reciprocal, which is cosine. So depending on how you want to do this function, we can do it both ways. But either way, I'm going to need to use the derivative, this natural log of u, which is du over u. That is my chain rule variant for natural log. So doing it this way with product rule, you're going to get f prime of x. The derivative of natural log of x squared is going to be x squared on the bottom because that's my u, and the derivative of that of 2x on top times cosine x plus the natural log of x squared times the derivative of cosine x, which is negative sine x. If we were doing it with quotient rule, then you would get f prime of x, and again, it would be quotient rule, which would be low function, so secant x, times the derivative high, and we'd still end up having to use this formula here, and of course we would get the 2x over x squared minus the top function, natural log of x squared, times the derivative of low, and the derivative of secant is secant x tangent x all over secant squared x. And again, you would end up getting down to what we got right here if you simplified it a little bit. But that's why I tend to rely on product rule when I see these trig functions. Using some of my trig identities makes it easier. Okay. Now the last one really shows where this shines. So let's look at the derivative of the square root of u, which is du over 2 square root of u. Okay? So using this chain rule variant, I have the square root of u. So automatically I can write this on the bottom, because I know from this rule right here, I'm going to get 2 over whatever I started with. Then we just take the derivative of the inside and put it on top. Now I have a chain rule here because I have x squared inside of the tangent. So we can use inside-outside rule if we want to, or we could use the chain rule variant, however you want to do it. But I'm going to do inside-outside. So 2x times the derivative of tangent, which is secant squared x squared. And that's my derivative. And when you have these formulas memorized, it makes your life a whole lot easier. And then using the formula as well as the inside-outside rule to take or find this derivative here, a derivative that would normally take us a couple minutes boils down to less than 10 seconds if you know what you're doing. Okay, so make sure you have these rules memorized. The best way of doing that, I find, is flashcards, and it's using spaced repetition to memorize them.